Exercise 1. The adjacent diagram shows a standing wave on a string. Mark the positions of the nodes N and the antinodes A or AN. Explain the formation of the node and antinode. The standing wave in the diagram is drawn to a scale. Use the ruler to represent the wavelength. Use a ruler to represent the amplitude of the standing wave by capital A, and use the amplitude A of the progressive waves on the string. Mark the positions of N and A. N, it's clear, N are the points at which node displacement takes place, and antinodes are those that undergo maximum displacement. Explain the formation of a node and antinode. I'm going to attach a link in the description box. There is an animation in this website that makes things clear concerning the standing wave and the formation of node and antinode, and how do two crests meet undergoing constructive interference, and how does a crest and a trough meet and undergo complete destructive interference, knowing that the two waves have the same amplitude. So now the formation is explained as such. The formation of the nodes and antinodes in a standing wave pattern can be referred to the interference of two waves of the same frequency. It is necessary that these two waves have the same frequency. The nodes are produced at positions where complete destructive interference occurs. The crest of one wave meets with the trough of a second wave, or half crest of one wave meets with half trough of a second wave, such that the amplitudes are equal but have opposite directions for orientations. The antinodes are produced at positions where constructive interference occurs. The standing wave in the diagram is drawn to a scale. So here you have the blue segment represents the wavelength, because if you consider, for example, the incident wave, it includes a trough and a crest. So this is the distance here is the wavelength, and this vertical, the red segment represents the amplitude of the standing wave. Now we use the amplitude of the progressive waves. When you check the link in the description box, you're going to see that when at the crest and the crest, when a crest of the incident wave and a crest of the reflected wave meet, they're going to add up to each other. So because they already have equal amplitude, so this means that the standing wave have double the amplitude of the propagating wave. So moving backwards, we have to divide the amplitude of the standing wave by 2 in order to obtain the amplitude of each one of the propagating waves. So here it's 2 centimeter divided by 2, which is equal to 1 centimeter. Exercise 2. A standing wave with one complete loop is established along a string of length 80 cm whose both ends are fixed. The string is vibrating with a frequency of 20 Hz. What is the name given to the 20 Hz frequency? Because one complete loop, so this is for n equals the 1, then this is first harmonic frequency or fundamental frequency. Calculate the wavelength of the progressive wave on the string. Calculate the wavelength having that there's a standing wave taking place and given the length of the string, so you can apply the condition for a standing wave and lambda over 2 equals L. Substitute L equals 80 cm and equals 1. Then lambda is 160 cm. Now calculate the speed. V equal lambda times F. We are given the frequency and we calculated the wavelength. We have to convert from centimeter to meter by dividing by 100. 1.6 meter times 20 Hz equal 32 meters per second. Now, what are the frequency of stretched string depends on its length. So give 2 factors that affect the frequency of a stretched string. The factors are length, thickness, density, and tension force. You know that if we apply the same force on 2 strings of different length, in which one is longer than the other, the response is going to be different. Similarly, for the thickness, if 2 strings have the same length but of different thickness, so more thickness of the same material means more mass, and more mass means it's heavier, and so applying the same force to a heavier string would not cause the same response or the same interaction or the same the propagation of the same wave through the string. So these factors do affect the wave that propagates through a medium. And you have the density here, which is the mass over volume. I've just discussed it. It includes both the thickness and the mass and the length. And finally, the tension force, which is the force that is used to fix the ends of the string, for example, and stretch it. Maybe the tension force will be so strong that the string is completely stretched, or maybe the tension force is not that strong, so the string is kind of loose but with fixed ends. So the reaction also, or the response, differs. Finally, for the fifth question, which is draw diagram of the string when it vibrates at its second harmonic frequency. Second harmonic frequency means n equals 2. Specify the value of the second harmonic frequency. So as long as the wave is still propagating through the same medium, so the speed is going to be constant. Now having the same, okay, of course, the same string, the same length. So second harmonic frequency n equals 2, applying the condition of standing waves, and lambda over 2 equals L. So n2, we get that lambda now is 80 centimeter, and f equal v over lambda. V is the same as the one we calculated in the previous part, because the same nature of wave is propagating through the same medium, and we know that speed is dependent on the medium, not on the wave. So v remains the same, and lambda is calculated. Now we get 40 hertz. Now for the representation, we have n equal to 2 loops, so a complete cycle for the incident and a complete cycle for the reflected. We have to consider a scale here, because from this point to this point, or from this end to this end, this is a whole complete wavelength. As you can see, it includes a crest and a trough for an incident wave. So you have to consider a scale here. I considered 1 centimeter on the paper to be 20 centimeter in reality, so that's why when I draw it on the paper, I draw 4 centimeter long string. Okay, so this is it.